So again, first, the elements, when they are not combined, the charge is 0. Hydrogen can either be positive or negative. It depends on the combination that you have. If it's combined with a metal, it's always going to be -1 because the hydrogen takes the place of the anion. Oxygen is -2, except in peroxides where it is -1, and when it is combined with fluorine where the charge is +2. But those are exception of the rules. Okay? Then metals in ionic compounds always have positive oxidation number. For example, iron. Iron can be +3, +2. Just positive, nothing negative. But in covalent compounds, the negative oxidation number is assigned to the most electronegative atom. Remember when we talk about the electronegativities to see if it's covalent, polar covalent. Okay, those electronegativities are going to help us to know if we have a covalent compound, which one is going to be the negative charge. So the negative charge is going to be for the element that is the most electronegative. Then the two more important rules are the following. When you add the oxidation numbers of all the elements in a compound is going to be equal to 0. And when you add all the oxidation number of all the elements in a polyatomic ion is going to be equal to the charge of the ion. Now, the solving strategy for oxidation number is the same that I explained to you the other day. Okay? We're going to write the oxidation number of what we know. We're going to multiply times the number of atoms. And we're going to equalize to 0 or to the charge of the ion in case that we are working with a polyatomic ion. Just remember this. The sum of oxidation number in a compound is 0, but in a polyatomic ion is equal to the charge of the ion. So take a look here. I'm going to do examples for compounds and ions. Remember this. How do you identify the number of atoms? Because of the subscript. The subscript is the number of atoms of an element. So I'm going to give you an example for a compound. Remember, when we have a compound means that it doesn't have a charge. That's the most important characteristic. So take a look to this example right here. I say, guys, I want you to find, the oxidation state or oxidation number of all the elements in this compound. And that's the compound. First of all, what's the name of that compound? Would you say the name?
Calcium nitrate.
Calcium nitrate. I'm just testing if you know how to name, okay? I remember that once I was so angry with my students that I told them, if you don't pay attention today and you don't know how to name those compounds, then all my exams from now on are going to be in words. Nothing, not a single chemical formula. So everything you have to write the formula from the name. So I force them to actually know every single element and every single polyatomic ion because of that reason. And remember that it was a lot different like 2 or 3 years ago than it is today. So calcium nitrate. First of all, how do we identify that it is a compound? Take a look what I wrote right here. It says compound has no charge. How do you know if it doesn't have a charge? How do you identify that it's a compound and not a polyatomic ion? Take a look. What charge do you see above? What charge do you see above?
Anyone?
Anything. There's nothing there. Okay, no charge. Because it doesn't have a charge, you can say, ah, that's a compound. So what happens when you have a compound? When you have a compound, the rule says that you must equalize to zero. Okay? The formula must be equalized to zero. So now we're going to see the atoms of each element. Take a look. I have one, two, three elements in this compound. Okay? Calcium, nitrogen, and oxygen. How many calcium atoms I have in this compound? How many calcium atoms? What's the subscript?
1.
It is invisible 1. Okay, you don't see it, but it's there, is invisible 1, which means that you just have one calcium atom. Okay, now we're going to move on to nitrogen. Let's see how many nitrogens do we have. What is the subscript in nitrogen?
3.
Hmm. Take a look. This 3 belongs just to oxygen. But nitrogen, it doesn't have any number below, which means it is invisible 1. Okay? Invisible 1. So you have actually one nitrogen inside the parentheses. But outside the parentheses, you have these 2. So you need to work with that 2 that is outside the parentheses. Now, take a look. Remember when in math class, they taught you about distributive property. For example, distributive property says that the number that is outside the parentheses is going to multiply everything inside. So this is the distributive property, allowing the number outside multiply everything internally. So in the end, the answer to this multiplication is going to be 2 times x, 2x, to copy the sign, and then 2 times 1, which is 2. This will be the answer of multiplying by using distributive property. Now, you apply the same concept, you apply the same idea in chemistry, but it looks quite different. So in chemistry, how are you going to apply the distributive property? The 2 that is outside the parenthesis, the number outside the parenthesis, is going to multiply everything inside. So these 2 will multiply the number of atoms of nitrogen, and these 2 will multiply the number of atoms of oxygen. That's the distributive property in chemistry, okay? So, for nitrogen, how are we going to calculate the number of atoms? So, you're going to put the number that is outside the parentheses will multiply the number that is inside the parentheses. 2 times 1 nitrogens. And then we move on to oxygen. Now, how are we going to calculate the oxygen? how are we going to calculate the oxygen? Again, I repeat, the 2 outside the parentheses will multiply the number that is inside the parentheses, that is 3. And because it is a compound, will be equalized to 0. Remember, we do this because it is a compound. Okay, once you do all this, you need to replace the element by the charges that you know. For example, calcium. What is the charge of calcium?
1.
Calcium is 2. Look in your periodic table. Calcium belongs to the group number 2. And the group number 2 says that all the elements in the group 2 has the charge positive 1. Positive 2, sorry. So in the end, calcium has a charge of positive 2. And what is the charge that we know for oxygen?
-2.
Negative 2. Okay? Now you're going to substitute the elements that you know by the charges that you already found. But now tell me, before I continue, tell me, what is the charge of nitrogen?
2.
Look, look in your periodic table and tell me, what is the charge that it appears for nitrogen?
Positive or negative 3, 5, 4, and 2.
Positive and negative, 5, 3, 4, and 2. So there are too many options. I don't know what's the charge because there are too many options, okay? So which one am I going to choose? Which one? I mean, there are many possibilities. Because there are many possibilities means that I need to find the oxidation state for nitrogen in this compound. So to know that, I will use my nitrogen as a variable, as the unknown of the problem. Okay, so right now we're going to substitute the element by the charge. Calcium, the charge is positive 2. Now 2 times 1 gives me 2 times 1 gives me 2, and this multiplies my unknown, which is nitrogen. And then 2 times 3 gives me 6 oxygens. Okay, 6 oxygens. This is equal to 0. I'm gonna leave this as calcium again. Okay, now I'm going to substitute the element by the charge. For example, here, calcium is positive 2 plus 2N, that is the nitrogen, plus the charge of oxygen, we already defined it, is negative 2. Okay, so we write the charge negative 2 right there, and we equalize to 0. So now we're going to solve for the multiplications. 1 times 2 gives me 1 times 2 gives me 2. Thank you for your participation. Plus 2, which is N. 6 times negative 2, that gives me negative 12. Again, thank you for your participation. Now, what's the procedure that it follows? Better like this. What's the procedure that it follows? I need to add or subtract the like terms, okay? So in this case, the like terms are 2 and 12. What is the answer of 2 minus 12?
Negative 10.
Negative
Negative
10.
10. Exactly. So you have 2n minus 10 equal 0. And now we begin to isolate. The 10 which is making a subtraction and the other side will be doing an addition. So you will have 2n equals 0 plus 10. And 0 you can totally ignore it because it's doing nothing. Okay? Now, what is that 2 doing to the n? Is it multiplying or dividing?
Multiply.
So when you
Multiply.
send it to the other side of the equation, we'll be doing a division. So nitrogen is going to be equal to plus 10 divided by 2. So nitrogen is equal to positive
5.
5. And this will be the oxidation state for nitrogen in that compound. Positive 5. Remember to be careful in the isolation moment, okay? Because the negative 10, when it goes to the other side, goes positive. And that's it. That's the procedure for oxidation number of an element in a compound. But sometimes we're not going to have a compound. We're going to have a charge. So let's take a look. In the case that I give you an ion, take a look. How do you recognize the ion? Take a look to this. How do I know that is an ion? How do I know that's an ion? Is there
By
something?
charge.
The charge, exactly. Above the formula, you see there is a charge. There is an exponent, okay? That exponent represents the charge. So if you have a charge, means according to the rule that you will equalize to the charge, okay? In this case, the charge is negative 3, so this is going to be equal to negative 3. Now, what we do is we're going to list the elements and the number of atoms. Okay, the first element that you see in the ion is the element phosphorus. How many phosphorus atoms I have in this ion? Remember, the atoms are the subscripts. What's the subscript in phosphorus?
1.
Invisible 1, okay? So you have 1 phosphorus. How many oxygens I have in this ion?
4.
4 oxygen atoms. Those are the only two elements, so I'm going to equalize, not 0, I'm going to equalize to the charge, which is negative 3. Now, what is the charge in your periodic table? What is the charge for phosphorus?
Positive and negative 5, 3 and negative.
Positive, negative 5, 3. That's it.
And 4.
Okay, so as you can see, there are many possibilities. Again, there are many possibilities, so I don't know what is the charge that phosphorus is using here. So this is going to be my unknown. Now, what is the charge of oxygen?
-2.
-2. So right now, I'm going to use all that information to solve this problem. So I say 1 phosphorus, or just phosphorus because we can totally ignore the coefficient 1, plus 4 oxygen. Oxygen has a charge of -2. This is equal to -3. Now we solve for the multiplication. 4 times -2. How much is that?
-8.
-8. And now 8 is doing a subtraction, so in the other side we'll be performing an addition, okay? So the -8 goes to the other side of the equation by doing addition. How much is this?
5.
Positive 5. Positive 5. Now if you take a look, nitrogen gave me +5, phosphorus gave me +5. So does it mean that all oxidation numbers are going to be +5? Let's take a look to this other example. And then remind me that I have to talk about the peroxide. Take a look to this example. It looks very similar, but in the end it's different. Above we have phosphate ion, and below I have a phosphite ion. So it is different. Okay, it is different, though the charge is almost the same, but the oxygen is different. Okay, so it means it's a different ion. This is phosphite ion. So we're going to calculate the oxidation number for it. Again, we're going to follow the same procedure. Phosphorus, I have invisible 1 phosphorus, okay? I have invisible 1 phosphorus. So it's going to be 1 phosphorus plus how many oxygens?
3.
3 oxygens. And I'm going to equalize to what?
To
-3.
-3.
To -3. Now, do I know the charge of phosphorus, or there are many possibilities?
There are many possibilities.
There are many possibilities, so it is my unknown. For oxygen, do I know the charge?
-2.
-2, okay? So now we substitute. 1 times P is going to give me just P, plus 3 oxygens, that is 3 times -2 equals to -3. 3 times -2 gives me
-6.
-6 equals to -3. And now the -6 goes to the other side, positive. So P is going to be equal to -3 plus 6. So what is the oxidation number for phosphorus in this case?
3.
+3.
+3. So as you can see, the oxidation number is going to vary. Okay, it's not always going to be +5. Now listen to me. A student from the other section, she asked me about how I recognize peroxide, because as you saw, the rule number 3 says oxygen is -2, except in peroxides where it is -1. So I'm going to write two examples here. The first example is going to be this one. Okay, first you have to see the peroxide ion. Peroxide ion, it is in the polyatomic ions table that I gave you. Okay, peroxide ion is written as oxygen, subscript 2, and the charge is -2. Okay, that's what it says. So let's say that I combine, calcium and peroxide. Okay, calcium and peroxide. Calcium has a charge of 2 plus and peroxide has a charge of 2 minus. So what happens with the charges? They are cancelled. So if I combine calcium and O in peroxide, I'm going to have calcium peroxide. And the formula, as you can see, is CaO2. Now, I'm going to show you what if I just combine calcium and oxygen. Calcium and oxygen. Calcium is 2 plus and the oxygen is 2 minus. Oxygen doesn't have any subscript because it's just oxide. So, what happened with the charges? The same. The charges are cancelled. Sorry, calcium here is positive, okay? Now, anyway, the charges are cancelled. And in the end, this is the compound that you have. Calcium oxide, not peroxide. And the formula, as you can see, is just CaO. Now, what makes the difference? The subscript in oxygen makes the difference. In peroxide, the subscript is 2. Okay? So, that is how you identify the peroxide ion. Now, you want to make sure that it is peroxide, do the procedure. Okay? You don't know if it's peroxide, work with oxygen as unknown and work with calcium with a known charge of 2 plus. Let's find out if it is peroxide or oxide. Take a look. This is a compound, so you have how many calcium atoms I have and how many oxygen atoms I have. How many calcium?
1,
One calcium atom, invisible one, okay? And how many oxygens?
2,
Two. Because it is a compound, is equal to 0. 1 times calcium is just calcium plus oxygen that is going to be unknown in this case. 2 oxygen is equal to 0. The charge of calcium is 2 plus 2O is equal to 0. Isolate for oxygens is going to be 2 oxygens equals 0 minus 2 because the 2 was adding, now is subtracting. You can totally ignore the 0. And then isolating for oxygen will be -2 divided by 2. So in this case, oxygen has a charge of -1. This indicates that the oxygen there is actually from peroxide ion, okay? Because it gave you -1. Now, in the case below where we have calcium oxide, is slightly different, but that slightly difference is making the real difference in the end. Take a look right here. How many calcium atoms I have in this exercise? How many calcium atoms I have? And how many oxygen atoms I have?
One and one.
Exactly. I have one calcium and one oxygen. They are invisible, okay? Now it is a compound, so it's going to be equalized to 0. Now you know the charge of calcium, which is 2 plus. And remember that you don't know if that is oxygen or peroxide. So you will look for oxygen. So this will be 1 times 2 plus 1 oxygen, or just oxygen, equalized to 0. 1 times 2 makes 2, and oxygen equals 0. Now isolate for oxygen. This is going to give you 0 minus 2. Remember that you can ignore the 0. So in the end, you see that O, or oxygen, is equal to -2. And this ion is what we know as oxide ion, or the normal oxygen that we use in compounds. So, two ways to identify the